Hey students, so we are watching Unit 1 Day 5 videos. There are 3 videos that I'm combining together. You need to give yourself about 45 minutes to do these videos. Answer the questions when I stop and ask you questions. You're going to need your vocab folder. You're going to need your Unit 1 Day 5 notes, couple of highlighters, and maybe your calculator. So this video is a little choppy. I told you sometimes it was choppy, and that's okay. I think you can still understand it. So what I need you to do is to be diligent with your notes, write them all down. I will say at the end of the video, start the next video. It's going to start automatically, so no big deal. If you have any questions, be sure you let me know. Also, make sure that you're always watching and listening to the videos. Thanks. Here we go. So we are on page number 5, and we are starting the angle unit. So you should be looking at, we have these done, so you should be looking at these 4 right here. So if you will, go ahead, just a little, so we can get this all in here. Okay, if you'll pause the video, start copying these down. When you get over here, be sure you're using a straight edge to make everything neat. Make sure it looks neat in your notebook. Remember, this is an easy A. You have to do what I'm telling you to do in order to get that A. Go ahead and pause the video and then copy this down. And when you come back, I'll go over it. Okay, so let's go over this. We are in the unit on angles. Our notes will go in a little bit more deeper with how to name things, so we're just going over the vocab. So definition of an angle is a figure formed by 2 rays with the same end point. The point in the middle is called the vertex. The sides are rays, and we'll talk about that more in detail on your notes. By the way, vertex is vertices, and you might see that on a crossword puzzle. If I had a triangle, pretend that's a triangle, it would have 3 vertices. That actually shows up in the triangle section, the triangle unit. Next, we have degrees. So degrees, angles are measured in degrees. That's how we take a measurement. You can actually use a protractor and measure an angle, and it tells you a degrees. We don't do that anymore in geometry, or it's really not necessary. But we will write it, angle A equals 48 degrees. Now, sometimes I write the angle with just the angle symbol. Sometimes I put measure in front of it. Sometimes I put this little marking here. There's lots of different ways you can write angle. You will actually see different ways. The part with the measure in standard geometry, I don't really make you, I don't hold you responsible for that, and that's okay. So angle A equals 48 degrees. Okay, then we have acute. Acute and right. So an acute angle, you should know these, is an angle, and I did have typos here, an angle that measures more than 0, but less than 90. Think about it. An angle can't be 0 degrees. If this was closed all the way down to 0, a 0 degree angle doesn't exist. It's a ray. So it has to be more than 0, but it can't be 90, because if it was 90, so an angle that's between 0 and 90, you might see the vocab definition that way. Again, I wrote angle C. You can put the measure of angle C equals 25 degrees, and acute is between 0 and 90. Okay, then we have right angle. A right angle is an angle that measures exactly 90 degrees. In order to be a right angle, we do have to put this little box in here. So do you know what a carpenter square is? In carpentry, a person who builds things might use a carpenter square to make sure that when things meet up, that they actually meet up at right angles, because you can't build a kitchen table if one of the sides is off a little bit. That would not fit when you get down to the other corner. So they use carpenter squares to make sure things are meeting at right angles. If that little marking is not there, then unless there's some other wording that says it's a right angle, you don't know that it's a right angle. Right angles must have either the wording or the mark to tell you they're right angles. All right, the next page, I'm going to let you pause. So go ahead, get that down for you. We've already done this one. So pause and copy these down and be sure you're using that straight edge. Okay, if you didn't pause, go back and pause, and I'm going to go over these. So an obtuse angle is an angle that's more than 90 but less than 180. So I put 110 degrees. At the top part, it's only up, and I wrote it like this. Angle F equals 110. You can put measure of angle F. It's all talking about the same thing. Then we have a straight angle. A straight angle is any angle that measures exactly 180 degrees. So you notice if I were to talk about opening this angle up, it is starting at 0, is going to 180, and yes, it looks like a straight line. So the actual definition is an angle that measures exactly 180 degrees. Then we have angle bisector. There's a lot going on in here. So first of all, it's a ray. I've got it highlighted. Notice there's an arrow here and a point here. That is a ray. A ray that divides an angle into two congruent angles. Remember, if you're a bisector, then you have to be bisecting something. And so what this bisector is doing is it's cutting angle ABC in half. So let's look at some markings I have in here. So first of all, if this angle opened up to 80, each of these little ones would open up to 40 because this angle this ray cut the angle in half. All right, well, we have these little markings right here. Remember when we had midpoint? And we had some markings to tell us that AM was congruent to MB. And we know that if we see the markings, we know these two pieces are equal. But we can also do that with angle bisectors. And I put the two markings here and here. So you just draw a little arc and you put the markings to show that they're equal. Okay, now another thing that I did was I put a 1 and a 2. You're going to learn on the notes that you can label angles with numbers. You can put the numbers in, or sometimes they're already in there. And so I can say angle 1 is congruent to angle 2. We're going to learn how to name the angles on the notes. I can say angle ABD is congruent to angle DEC. And we're going to see all of that on the notes. All right, we have one more thing to do, and these are out of order a little bit because they actually show up in this unit, but we use them now. So would you pause the video and write down what's on this page, and then we'll talk about it. Pause the video, because I'm coming back right now. Okay, so perpendicular lines are lines that intersect at right angles. So these two lines are intersecting, and they're forming a right angle right here. Now remember, if there's a right angle here, there's also one here because these are going to add to 180. 90 plus 90 is 180, which is the straight angle. And then there's also a right angle here and a right angle here. We just don't typically put that in all 4 places. If it shows up in one, then you know it's in all the other places. This is the symbol for perpendicular, and this is some notation that you might see. I would say line AB is perpendicular to line CD, and that's how we would write that. All right, if I add one more word to this definition and say perpendicular bisector, so what does a bisector do? It bisects something, but this time we have perpendicular with it, so there's 2 things going on. These are perpendicular, so there's the right angle, and if it's bisecting the segment, by the way, a perpendicular bisector can only go through a segment, then it has to be cutting that segment in half. So 2 things are happening in a perpendicular bisector. We have right angles that are formed, and have 2 segments that are now congruent. So perpendicular bisector makes right angles and congruent segments because M is the midpoint. All right, we're done with the vocab. I think it's really important that you copy vocab down and then you go back and listen to it so that you can understand it. Okay, so what I want you to do is to pause the video and copy this down, and I'm going to start a new video. So after you copy this down, you can stop the video and you will start the second video. Okay, here's the second video. I'm going to make it bigger for you so you can see it. Again, pause the video and copy down that first part and then let the video run. This segment is 11 and a half minutes long. Hello, students. We are finishing the video notes for Unit 1, Day 5. So I'm going to talk about this kind of quick. These are a review of the vocab that we just did, so we can go through this very quickly, and then I can point out some new things to you. All right, so talking about an angle is formed by two rays with a common endpoint. Two rays with a common endpoint. The common endpoint is called the vertex. The rays are called the sides. We can name an angle using three letters. Three letters. This is really important. All the notation that we've talked about, it is important that you know how to name an angle. The way you name an angle is the middle letter must always represent the vertex. So if I was going to name this angle right here, I can name it angle A, B, C. I can turn that around and name an angle C, B, A, just like I have written here. I can also use a single letter if there is only one angle located at the vertex. So I can call this angle B. And then sometimes we're going to have numbers thrown in here, which makes life a whole lot easier for us. I could call this angle 1. Here is an example of where you cannot say angle B, because there's two angles together. If you said angle B, I don't know which angle you are talking about. So if it's just a single angle, you can call it by the letter at the vertex. Those are the four types of angles that we had, which you already know. So let's go through and do some of these problems and see what we can figure out. So in this picture, name the vertex of the angle. The vertex is just K. It's a point. Name the sides of the angles. The sides are made up of what? Rays. Remember how we name a ray? What do you start with? The end point. And you go to the letter by the arrow, and you draw the arrow going to the right. And then we start at the end point, and we go to the letter by the arrow, and we draw the arrow going to the right. Give 3 ways to name the angle. Okay, so 3 ways. I can name this angle JKL. I can name it angle LKJ. I can name it angle K. Now, that looks like LK. It's just how I do my angles. You gotta get used to that. That's angle K. I'll try to make that better. And then actually, if I put a number in there, let's put a 2. I can say angle 2. Okay, so Miss Kotler, she does this with her angles. I don't, so you're still going to see me. It'll look like an L every single time. Okay, now letter D, classify the angle. Classify means use a vocab word. So what would you use to describe this angle? And we're looking at these 4 words right here. It is obtuse. All right, so what I want you to do is to try to answer example 2 by yourself. Pause the video, and then I will uncover it and have the answers. All right, answers. I threw a 3 right there to give us 4 ways to name the angle. And so the vertex is S, the sides are ray SR and ray ST. 3 ways to name the angle: angle RST, angle TSR, angle S, and if there's a number there, you can name it by the number, which you didn't have, and that's okay. Classify the angle, one of the 4 words up here, it is a right angle. Okay, congruent angles, we're not going to worry about this, but congruent angles would have the same measure, and so if 2 angles have the same measure, then the angles are congruent. Angle A is congruent to angle B, and so let's put if they have the same measure, and I totally filled that in with just my own words. If they have the same measure, then the angles are congruent. Okay, flip to the next page. I want you to pause the video and write all of this down, and that will help us go through it quicker. Right now, pause the video, copy it down, and we'll continue when you get finished. Okay, so let's go over this. So an angle bisector is the ray, that's ray BD right here, that divides an angle into two congruent angles. So these two angles are congruent. In the diagram, ray BD is an angle bisector. Here's how you show the two angles are congruent. You can also show angle 1 is congruent to angle 2, or you can say angle ABD. Now watch my pen when I do that, because this is going to be a struggle for some of you. Angle ABD, that's this angle here, and angle DBC. Those are the two angles that are congruent. Now look at how they did this. This looks like one big curve, but really it's two markings. It's one here and one here. They have the same marking, so that shows that these two angles are congruent. Perpendicular lines, lines that intersect at right angles. There's the right angle, the symbol for perpendicular. And in the picture to the right, line M is perpendicular to line L. And then we have perpendicular bisector. Perpendicular bisector, remember two things. We have to have the right angle, and we have to have a midpoint, meaning these two segments are congruent, and there's actually a midpoint right here. In the diagram to the right, LM, line LM, is the perpendicular bisector to segment PQ, perpendicular bisector. Okay, so example number 3, we're going to identify some things in this picture. Write another name for angle CBF. I don't even need to see that picture to do it. I know that I can switch it around, angle FBC. Okay, I can switch it around. That's one way to write it. There's no numbers, no other way that I could do that. Name the sides of angle EBD. So angle E, watch my pen, EBD. The sides are going to be ray BE and ray BD. Classify angle ABC. So watch my pen. ABC. Out of those 4 words that we had before, what kind of angle is that? It's a straight angle. Give an example of an obtuse angle. In this picture, do you see a big angle that's bigger than 90 degrees? There's several of them. So let's use angle DBE. Angle DB. Now if I do this, that's 90. So if I go bigger, angle DBE right here is an example of an obtuse angle. There's others. I could say angle, let's see, if I did DBE, maybe, okay, that's good enough. All right, name 2 congruent angles. So look at the markings. If I look at the markings right here and here, that shows 2 congruent angles. And so be sure you know that you're naming 2 things. So I named this angle ABE. Remember, you can say EBA and get the same answer. And then angle CBF. Name a perpendicular bisector. So remember, this is the one doing the cutting. Okay, the perpendicular bisector. If you're the bisector, you are doing the bisecting. So if you look at this segment right here, it's been cut in half. So the perpendicular bisector is ray BD. Ray BD is what's cutting it in half. Very good. All right, so I want you to pause the video and work out the next section. Get as many answers as you can. When you come back, we'll talk about them, and then we'll move on to the next part. All right, here we go. So name the vertex of angle 2. Angle 2 is right here. The vertex is T. Okay, angle 2 is this angle, and the vertex is T. Name the sides of angle 4. Angle 4 is right here. The sides are ray TW and ray TZ. Name another name for angle 3. Angle 3 is right here. So you can say angle ZTU, or you can say angle UTZ. Either one the same, forwards or backwards, it's the same thing. Give another name for angle 1. Angle 1 is right here. You can say angle XTY, or you can say angle YTX. The only thing you can't do on these angles is say angle T, because I don't know what angle T you're talking about. You can check those. Angle YTW, so when you're finding it, trace it with your pen. Angle YTW is a right angle. Angle YTU, angle YTU, that's obtuse. Angle XTU, that's a cute little angle. And then angle WTX is this straight angle. Name 2 perpendicular lines. So perpendicular would have to make the right angle. So this line right here, I said line YZ, and then line WX. Make sure the line symbol is above it because it said line. And then name an angle bisector. So which angle's been cut in half? So this is the angle that's been cut in half. So the angle bisector is ray TU. Ooh, bonus question. If this angle is 90, this angle's 90, this angle's 90, this angle's 90, what are each of these? Ooh, 90 cut in half would be 45, 45. Did you get that answer right? All right, we're going to move on. So I'm going to start a new video, the 3rd video, and we'll finish the worksheet. It will be the longest one out of all of them. And so turn over to the next page and you'll be ready to go. All right, students, go ahead and take a little break. Pause the video, take a break. And when you come back, we'll be ready to start the 3rd one. The 3rd one is 16:47. 16 minutes, 47 seconds. I told you this was a long set of notes. So here I go. For Unit 1, Day 5, we're on. Here we go. Hey students, we are on the 3rd video for Unit 1, Day 5. We're on the 2nd page. And a lot of these problems, the algebra is going to be repetitive, kind of like it was on the algebra that we did on the last set of worksheets. And so I'm going to go a little bit quicker with this and just pause the videos and give you time to work out the problems. And you're going to see that the algebra you already should be comfortable with. It's just setting up the problems. Okay, so this page is dealing with the angle addition postulate. We're going to say AAP for angle addition postulate. And what that says is that if you have a picture and you have 2 angles, those 2 angles are going to add together to give you the big angle. So angle ABD, this angle here, plus angle DBC, this angle here, is going to add to equal angle ABC. This is just like the segment addition postulate, but with angles. Now, another thing we can do is I can just put numbers in here to show you what I'm talking about. So angle 1 plus angle 2 are going to add together to give you the big angle. And if you're struggling finding the angles, trace the letters with your pencil and you will see that angle. Okay, so the first 2 problems are very basic problems. I'm going to label my picture. That's a big deal right now to label your diagram so that you can see what you're doing. So in the first one, angle ABD. ABD is 48 degrees. And angle DBC is 78 degrees. And the question says, what is angle ABC? Well, we're simply going to add those together, add those 2 together, and we get 126 degrees. All right, the second one, I'll use green. It says angle DBC is 74. So I'll put 74 right here. And then angle ABC is 119. So when I label big angles, we're going to label it out here, just like we did the segment. So angle ABC is 119. Find angle ABD. So this time I'm going to subtract. 119 minus 74 would give me the angle here, which is 45. That should make sense to you because 45 plus 74 gives you 119. That is the angle addition postulate. You are going to need to label your diagrams. I talked about that we were doing worksheet day 3. It's very important to label your diagram so that you can see what's going on. Okay, number 3. It says angle PQR is 141. PQR, so we're going to put that out here. Okay, angle PQR is 141, the entire thing. So this is just like the segment addition postulate that we did the other day. So we're going to say 13x plus 4 plus 10x minus 1 equals 141. I'll do the algebra with you on this problem. 13x plus 10x, we're going to combine like terms. 4 plus a negative 1 is a positive 3 equals 141. Subtract the 3. 23x equals 138. And then divide by 23. Divide by 23, and you get x equals 6. X equals 6. This is telling me to go back and plug in, so make sure you're plugging into the correct thing. So PQS is this one here. So I am going to plug in a 6. So I'm going to say 13 times 6 plus 4. 13 times 6 plus 4, you can put that all in your calculator. Remember, all in one step. 13 times 6 plus 4. And that gives us 82. Then the next one, SQR. SQR is right here. So I'm going to say 10 times 6 minus 1. 10 times 6 is 60. 60 minus 1 is 59. And then I have a question for you. What should these two angles add up to? What should these two angles add up to? They should add up to 141. That's how you know you've got the problem 100% correct. These two angles are going to add to 141, and they do. Okay, go to number 4. We're going to label our picture. So angle DEF, that is the big angle that goes out here. So we're going to write it like that. Angle DEG is 5x plus 1. Turn my paper. And then angle GEF is 23. So if you did not label your picture, you would not know which two things are going to add to give you the other number. And sometimes they put it in different orders to mess you up. So my problem is going to be 5x plus 1 plus 23 equals 7x plus 4. Would you go ahead and pause the video, finish working that out, fill in all the answers, and check when you come back? All right, let's see if you got it right. So there's my work. You can check your work. I got x equals 10. Angle DEG is right here, so I plugged in the 10, and that gave me 51. And then angle DEF is right here, and I plugged in 10, and that gave me 74. Now, these two do not add together to give you anything, but the 51 plus the 23 add to give you the 74. That should make sense to you. Okay, so what I want you to do by yourself, stop the video, and I want you to do number 5 completely by yourself. Stop the video, do the problem by yourself. Okay, let's check and see if you got these right. So first of all, I labeled my picture. The 43 goes here, the 8x minus 20 goes here, the 10x minus 11 goes there. You are expected to label your pictures. You have to label your pictures in geometry. So then here's my work. I said 43 plus 8x minus 20 equals 10x minus 11. I got x equals 17. X equals 17. And then I had to go back and plug in, substitute in to find these two angles here. So here's the first one. I plugged in a 17, and 8 times 17 minus 20 gave me the 116. And then the 10 times 17 minus 11 gave me the 159. And then you could double check. 43 plus 116 adds to give you the 159. So I know that I am 100% correct. Students, if you are not doing this when I tell you to, you are not going to get the best learning you can from these problems. Make sure when I ask you to pause and work the problem, you pause your video and you work the problem and then you check. That is exactly what we would do in class, and I'm expecting you to do it at home. If at any time you get stuck on something and you don't understand it, I want you to take a highlighter and I want you to highlight the entire problem. That will be a signal that you had trouble. And if you have trouble on a problem, you are expected to come to me during class, at the beginning of class, or before school, and let's make sure that you understand that. Okay, let's flip over to the back page. Okay, on the back, number 6. So this question doesn't have any labels on it, and they actually gave us a vocab word in our problem. It says angle DEF is a straight angle. What does that mean? A straight angle has 180 degrees. So this right here is 180 degrees. And obviously from the picture you can get that. Angle DEG is 23x minus 3. Angle GEF is 12x plus 8. And so now we are going to say this plus this equals 180. Okay, like I said, you're going to be doing a lot of the work on this worksheet on your own. So go ahead and do that problem, set it up, and check your answers when you get finished. Okay, let's check and see if you have it right. If you haven't worked it out yet, please finish working it out before you continue with the video. So these two angles are going to add to 180 degrees. There's my setup. Okay, I worked that out. I get x equals 5. And then I went back and it wanted us to find these angle measures. Hopefully you didn't mess this one up. It is 180 degrees. And so then I substituted in here, got my two answers. How will you know you have this 100% correct? Is that these two angles are going to add to 180. These answers are self-checking. You guys should know that you've got it right. You won't even have to check with me. You're going to know you have it right if this plus this equals this on however the problems are set up. Okay, so number 7, I'll set it up with you. TUW is 5x plus 3. WUV is 10x minus 5. And then angle TUV, which is the big angle, is 17x minus 16. And we're going to do that like this. 17x minus 16. All right, there's our setup. Once again, get a little bit of practice. Go ahead and work out that problem. Pause the video. Come back when you're finished. Okay, here we go. Check your answers. So I am not showing my work in here. If you have a question, again, highlight the problem. But just to go over this again, 5 plus 10 is 15. 3 plus a negative 5 is the negative 2. And then what I'm doing is I subtracted the 15x over here, and I added the 16 over here, and I did that in my head. But you guys, if you need to show the work, please show the work. And then I divided by 2. So there's lots of different ways to work out this problem. I'm just not showing all the steps. If you have a question, please ask me. Okay, the next problem, the algebra is going to be the same, but the setup is one little extra step. So look at what I have highlighted. You're going to have some problems where the thing that you're going to put into the problem is in words rather than in an expression, and you have to write that expression. So the first thing that you're going to have to do is find the angle or whatever we have that's going to be x. So this says angle ECD is 6 less than 5 times BCE. Whatever is in this little statement right here, that's going to be your x. You have to have an x to get started. And then this right here is going to be 6 less than. So if I'm 6 less than, I'm taking away 6. 5 times x. And you're going to have to get used to writing that because it's going to happen a lot on our worksheets. So angle ECD is this. Angle BCE is this. And then angle BCD, which is the whole thing, is 162. So this is 162. Angle ECD is this one. That's 5x minus 6. And then angle BCE is x. If you don't find which angle is x, you can't put this in. You have to have both angles represented by something. So the angle that we know nothing about is going to get the x. This one we know something about. I've got it highlighted. This one we know nothing about. Okay, I am going to let you work this problem out again to get a little bit of practice. Go ahead and work that problem. Pause the video, work out the problem. See you in just a minute. Okay, here we go. So this is the setup. Make sure you know that x plus 5x is 6x. We work all this out, we get 28. So then it says angle BCE. Well, angle BCE is x. That's 28. X is 28. And then angle ECD I plugged in right here. And these two angles should be adding up to 162 degrees. Put the little degree symbol. And they do, so I know that it is 100% correct. Okay, so we're going to skip number 9. Number 9 is exactly like the ones that we did. We're done, so let's put skip. And we're going to go to number 10. We're almost done. All right, so number 10, we have some vocab words that show up. We're using this picture right here. So it says ray BD bisects. What does that mean? Cut in half. Angle CBE. Let's find angle CBE. CBE. So this ray has cut it in half. So this angle is equal to this angle. Put the markings so we know. And then it says BC is perpendicular to BA. So BC is perpendicular to BA. So this is a 90-degree angle. Okay. Let's see what we got. Angle CBD. Angle CBD is 3x plus 25. Angle DBE is 7x minus 19. Okay. Find angle ABD. ABD. So I want to find this angle here. So this is not difficult at all. All right, so first of all, because I had bisect, I have two angles that are equal. I'm going to set these two equal, just like we did on the other worksheet. This is the only time, because it said bisect, that we're going to set those equal. So let's put 3x plus 25 equals 7x minus 19. Subtract 3x. I'll show you all the steps on this one. Add 19. And then divide by 4. X equals 11. Okay, so x equals 11. For me to find the angle that I'm trying to find is angle ABD. ABD. And so what I need to do is I need to plug in the answer right here and see what that is, and then just add 90 to it. So I'm going to plug in 11. 3 times 11 plus 25. 3 times 11 plus 25 in my calculator is 58. So that is 58. And then all I have to do is add the 90 to it. And my answer is 148 degrees. So I know on previous worksheets, there was a struggle on the harder problems. Just understand there's basic things that are going to happen. Either we're setting things equal to each other, or we are adding the two angles to equal the big angle, or we're going to be given a vocab word to help us figure it out. And that's the part of geometry that's a little bit tricky with all the problems being different. Okay, so you are at the end of these notes. We will do the worksheet in class, so you do not have to do the worksheet. If you want to get a head start, you can get a head start, but you don't have to. Thank you for your time, and I will see you in class. Okay, students. Here I am. Coming. Okay, there I am. So go in to Google Classroom and mark that video as done. You need to be doing that on all the videos so that that colored circle turns gray. Thanks. See you in class tomorrow. Good job. Bye.